So we're going to go ahead and do an example showing how can we apply the equation finding the volume value of a certain graph rotating around a certain coordinate axis into use. Okay, so now the question asks, find the volume of the solid generated by the region bounded by the curve y equal to 2x times e to the minus x over 2, the line, the x-axis, and the line x equal to 4. So the first thing we can do is sketch first and see what this thing behaving, so that we can it just doesn't play much of a important role in the calculation part, but it's very important in the way that we perceive how the equation or how the function behaves and how it operates, so that we can apply the endpoints at each for the integral later on. Okay, so how do we first sketch this? There's two ways. The first way you can do is that you can plug in points, right? You can plug in points. You can do that. Or the second way, which is more intuitively, is that you can find the derivative, right? When you find the derivative of this curve and see how it behaves, it gives you a better, more general picture of the graph. Okay, so that we go ahead and find the derivative of y. Okay. Well, why do we find y? Because these lines are very simple. It's just the boundary. It doesn't have much of a function that's going on. We're only interested in the y function right here, y of x. So y prime, so that's equal to 2 e to the minus x over 2 plus. Now we have minus 1 over 2, so that's minus y x times e to the minus over 2. Okay. Okay. All right. So so let's see. We want to find its maximum points. See how is it doing, right? So the only local extrema exists where the y prime equal to 0. So we can go ahead and set this equal to 0. See what we have. There's an e to the minus x over 2, so we can pull that out. Okay, so we're going to pull that out. There's a common factor. So 2 minus x equal to 0. Okay, so we go ahead and draw a table. Okay, for x values. For x less than 2, right? X equal to 2, and x greater than 2. Okay, and y prime and y function. For y prime, for x less than 2, you know that the function e to the minus x over 2 is always positive for any x belong to the real, right? So these things will never be equal to 0. So we can cast aside that. You can look at the graph, but you can plug in any points in here, even to infinity, and that the values 0 doesn't exist. Okay, so we wouldn't worry about that. We only worry about this one. So x less than 2. So x minus x, the x less than 2. Therefore, you have plus. Okay. X equal to 2. 2 minus 2. That's 0. X greater than 2, 2 minus something that's greater than 2, that's negative. So you know that y will behave something like this. It will increase, okay, to certain points, and then it will decrease. Okay, so we know that this is local max. Okay, all right. So how do we go ahead and graph this? Well, let's go ahead and apply this maximum point. Alright, so we know that the maximum is at x equal to 2, so we know that's the maximum here. We can go ahead and plug in points, but they question doesn't ask us to do so. It only asks us to find the volume, right? So as to find volume surrounded, generated by this region. So we can go ahead and start at the first point as x equal to 0. X equal to 0, we plug in here that is y equal to 0. Maximum that we proved it, we evaluated is at equal to x equal to 2, and at 4 is going to keep decreasing as x greater than 2. We evaluated it earlier, so therefore it's going to be going like this, and it will go at x go to infinity, right, and y will go to y will go to approaching 0, because you can apply the L'Hospital rule in here. You can go ahead and apply L'Hospital rule. What happened to the limit at x approaches infinity? 2x e to the minus x over 2, and you can transform this into 2x over e to the x over 2, right? And you know this is infinity over infinity, and if you take the limit or do the L'Hospital rule, you know that you have a 2 and 1 over 2 e to the x minus 2. So x goes to infinity, this approaches infinity, therefore it's approaching 0. Okay? So the limit is 0, so you know that as x goes to infinity, it is 0. So you go from 0, you go to 2, you go to max, and then you go to approaching 0. And then you form a solid around the x-axis. Something like that, okay? So now we're going to go ahead and apply the equation that we just derived, which is the volume. This is in terms of y, right? You know that y is in terms of y is 0 of x, y equal to fx, and it's generated around the x-axis. Therefore, we apply volume, therefore we go to 0, because it's stop at x equal to 4, so therefore we go from 0 to 4. See the region bounded by these curve, right? Curve this x-axis and x equal to 4. So it's this region. It's this region. And this region, you know, is rotate and create a solid. Right? And we calculate the volume of that solid. Okay? This region rotate. Okay? So you have it pi, right? Y squared, but y in terms of x, so therefore 4x squared times e to the minus x, right, dx. Okay? Alright, so now this looks like a integral that we have to do integration by part technique. So we can go ahead and choose minus e to the minus x, du, and take the integrate, do the antiderivative of that, and let's go ahead and do it. Okay. All right. So we have minus pi 4x squared to the minus x, 0 to 4, minus the minus the plus, right? 0 to 4, 4x squared. Well, you pick x squared to be, or 4x squared to be v, it's the same thing, right? 4x squared, let's say 4x squared, okay? So 4x squared, take that to be v, so derivative of that would be ax, right? So you have pi ax times e to the minus x dx, okay? Now, minus 4 pi, so let's rearrange that a little bit. So minus 4 pi x squared e to minus x, 0 to 4, plus minus e to the minus x again, okay, pi ax 0 to 4, okay? Minus a minus, that's a plus, okay? But plus what? Plus 0 to 4, and ax, we choose this to be v again, so that would be a pi e to the minus x dx, okay? Okay, so now we rewrite it again. So here we have this result. So go ahead and plug in, right? So but we see here this pi all for every term. So let's put pi out. So here we have minus 4 x squared e to the minus x. Go from 0 to 4. Minus a x e to minus x, go from 0 to 4, minus a e to minus x, go from 0 to 4, okay? So we're plugging 4, here plugging 4, that is 4 to the cube, that's 64, right? So minus 64 e to the 4th, right? Put 0 in that 0, okay? Minus 4 plug in there, that is 32, right? So 32 over e to the 4, 0 plug in there, that's 0, and minus 8 over e to the 4th. Plug in 0 in there, minus, that's a plus. 0 in there, e to the minus 0, that's 1, so plus 8, okay? Alright. Minus 64 minus 32, that's minus 96. 96 and 8 is minus 104. So pi 8 minus 104 to the e to the 4th. Okay, or it's the same thing as writing pi e to the e4th minus 1 over 4 to the e to the 4th. And you know that this 8 e to the 4th is bigger than 104 because e is approximately that's about 150 something, 160. So it's still greater than 104. Therefore, this is positive, right? Okay, so we know that we have it appropriate for the volume value. So this is the volume value for the question that we had earlier. So thank you very much.